Hey guys, it's Joe and I believe it's Greg with FTI.
Yes, sir.
We're here to talk about converters mainly today. Try not to ask us overly specific questions about what converter you should get for a specific setup. The main goal today is to explain how a converter works and how we can potentially make your car faster with an aftermarket converter. So with that said, again, Greg with FTI. For the people that don't know who FTI is or what FTI does, you want to give us a quick rundown of how it goes over there?
Certainly. FTI, we are a performance transmission converter company. We manufacture in-house everything from scratch, torque converters, transmissions, billet covers, billet stators, everything. We manufacture our own parts. We provide performance torque converters from everything from monster trucks to top dragsters, pro mod, street cars, obviously. Anything that's performance. We don't do any stock type work whatsoever. We are specifically designed and engineered around performance. Been in the performance industry my whole life. I've been a racer since I was 20 years old. We started this company in 2005 and it's grown to what it is today. We move roughly 8,000 torque converters a year and about 1,800 transmissions a year, and that's just power glides and turbo 400s. So we can fulfill just about any need, but we are a specialist shop. We specialize in what we do. We're here to make your car go fast.
Nice, nice. And the torque converter we have in front of us today, I believe you were saying earlier, this is 6R80?
Yes, sir. This particular converter we brought, and I brought it open so we could show you guys what goes on inside a converter, is for a 6R80.
Okay. Is this a specific model for your 6R80 setup?
This would be our Street Racer Series, SR Series.
Okay.
This is the triple disc converter, which is the most commonly we use.
Okay.
It's the most popular one we sell. Of course, we offer them in different stall setups, stators, so forth, whether it's supercharged, turbo, naturally aspirated, heavy nitrous, whatever.
Okay. Is a converter like this, is this like a single disc, triple disc, double disc?
This would be what we call a triple disc.
Okay.
It has two clutches on this and then one clutch on this side, so therefore we get 3 effective clutch plates, which is this particular converter at 9.5 inches has over 200% more clutch surface area than your factory 12-inch converter that comes in them.
Nice. And the clutch material, is that, I know that these are, or I shouldn't say I know, you would know. Are these considered wet clutches since
Yes.
they're in a fluid?
These are wet clutches. I work directly with the engineers at Ray Bestis Powertrain to design this material. This is a carbon impregnated Kevlar. It's designed to be pulse width modulated. As many people know, in a tuning application, you're always trying to get rid of the pulse width modulation in a converter clutch.
Yeah.
This clutch is actually designed to be able to slip on a ply without burning up.
Nice.
There are different materials that can be put on here. There's red materials, a little more aggressive, but if you try to slip it in a pulse width modulation setup, it will burn the material.
Okay.
So, I mean, it's a specific material that we have made for our clutches.
So this is a more so what we'd call forgiving material?
Very
for
forgiving.
slippage?
Yes, very forgiving.
So I guess we'll start with the part that bolts to the engine.
Okay.
What would you call this?
This would be what we call our cover, and this is a billet cover. As you can see there, it's made out of a piece of billet. We machine it to fit. We machine it in many different bolt patterns, whether it's GM, Chrysler, Ford, whatever. In this particular situation, we're working on a Ford. So we'll machine these in different bolt patterns, different pilot sizes, so forth. This starts out as one large forging. It's just a blank forging. We machine them in-house on our CNC equipment.
And what type of, I know it doesn't really matter, but what type of steel is it?
This is 8620 material. We use 8620, 9310 on our hubs, and 4340 on the impeller hub.
Nice. So tell me how critical this is.
That is probably one of the most critical pieces of the entire torque converter. This is what's called your pilot. Some people call it the snout on the street terms. This is your pilot. This has to go in the back of the crankshaft, and this is what centers the converter to the transmission. So the converter, when you put it in and it's all flopping around, and everybody's going, why is it all flopping around? It's supposed to. This has to go into the crankshaft, and then there's a bushing in the pump that rides on the hub, and that's what holds the converter on center.
Okay.
If this doesn't pilot into the crank, you'll get vibration problems, premature pump wear, so forth.
Okay, nice. So what specifically does the hub interact with? I know it looks like since it's bolted to the engine, it's basically direct drive from the engine. So what in this package actually slips so that the car isn't moving forward when you're in gear? Okay,
let's get in depth into this a little bit. Maybe move a couple of these pieces out of the way so we can explain what happens here. Move the clutches on out of the way. We'll get to those here in a minute. It's going to take a few minutes to explain. So with this piece actually bolted to the engine, this is what drives your torque converter. This is called a turbine. Now I'm going to take the bearings off of it just for display purposes here. There's everything in our converters has bearings in it separate. There's no plastic washers anywhere in our stuff.
And it looks like those are roller needle bearings?
Yes, sir. All torn and roller needle bearings
Okay.
in the entire converter. So the turbine would be where your input shaft goes in to the
From
to
the
the turbine,
transmission
right? Your
into
transmission, right? So you have the engine driving the outside cover. This is driving your input shaft.
Okay.
The job of a torque converter is to drive the input shaft. That's its 100% job. You know, so this is called a stator. The stator's job is to redirect the fluid into the impeller side of the converter. It's called a turbine. This is your impeller. So let's stack this up so we have a better understanding of what we got to work with here. Okay, this converter, when it's assembled, is welded around this seam. So now when the outside of this converter rotates, you're driving this. This is the impeller. The flats on the hub, now with 6R80s, there's two different hubs. You have one with flats, you have one with slots. Depending on the model year, I believe the model year breaks at 13, where they have slots or flats. This drives the pump of the transmission. Now the pump, of course, supplies fluid pressure to the transmission, and it also sends fluid back into the converter. Now, so this rotates in this direction, so we've got to flip it over to understand what goes on. The big misconception in most converters is that fluid flows in a circular direction around the torque converter. This is incorrect. So this is kind of what I want to try to bring to y'all today, is to understand what makes a torque converter do what it does. They're torque converters, they're not horsepower converters. So understand that torque is the most critical thing we need to deal with here. How this works is this rotates with the engine. This basically slings the oil out of here. So it starts here and slings out at the end.
Okay.
On a rotation. So as it inertia spins the oil out the outside of the converter. The oil actually flows in a converter in a direction like this. So it goes in the inside of the impeller, comes out the outside of the impeller. Let's take the stator out of the equation. Take our bearing out. So this piece would be driving your input shaft, would basically be in this position right here. Now, if you look at that position, you'll see the blade is cupped this way. So as this is turning this direction, and that oil is slinging out the end of this blade, it's catching this blade, which is like a cup. It's grabbing it. So as it does, it rotates this piece, which drives your input shaft. So now your car is being driven by oil. It's a fluid coupling at this point. This is where the problem lies. As this rotates this direction, and this has oil pressure in it, well, the oil's coming out of this in this direction because of the angle of the fin. If you put these two pieces together, you'll note that the oil is traveling in this direction, while this is trying to rotate in this direction because it's mounted to the engine.
Exactly.
And you're going, well, that's not going to work very well. This is where the stator comes into play. This is the heart of the animal right here. The stator resides inside an impeller. It has a relationship amongst these three parts. We'll come back in a little bit and talk about that relationship. So as that oil is exiting this piece that's trying to go against this, it actually hits the face of this stator. It gets redirected by the stator. The pressure reaches in, and look at there, pushes on the fin on the inside.
Gets it going the other way.
This helps accelerate the engine. By doing so, this is where torque multiplication occurs.
Within a torque converter.
That's how, exactly, that's just how it works. Now you can change how much torque multiplication occurs. There's what's called stall torque ratio, and that's the amount of torque produced at stall. So the higher the stall torque ratio, the harder the converter is going to strike the tire. But the less efficient it's going to be in the back half of the racetrack. It's not going to couple as well.
Does lockup affect that value?
That's the beauty of the lockup.
Okay.
We can run a higher stall torque ratio converter to get the car off the line harder, faster, and then apply the clutch down track when we can only get to that 7 to 9% slip. Okay. We can apply the clutch to 0 slip. And we're going to get into how that clutch applies too.
Okay.
So different stator blades counts, different stator blade angles, different angles of the fin inside the pump, different clearances between the three parts in the marriage, all affect how the converter works.
Okay.
So I'm sure that you guys have heard a guy say, I got a 3500 converter, and it sounds like he's revving to the moon to drive off from the traffic light. The other guy's got a 3500 converter, and he drives away like a stock, yet both stalled at 3500. The one that's revving up real high is a high stall torque ratio converter.
Okay.
The one
so it has more torque multiplication on it?
Has more torque multiplication on hit, and the reason why it's revving high is because it's helped driving the motor.
Okay.
So, but even though both stall at 3500, that's going to get into picking the proper converter for your application, whether it's boosted, nitrous, naturally aspirated. You have to know which stall torque ratio to put into that. Bore, stroke ratio, gear, tire, weight. The definition of torque is the ability to move the momentum of weight. So you have to take all those factors into it when you're designing a converter. Something that appears this simple You have to take all these factors into it.
I can assure you, it may seem simple to you, but this is complicated to me.
Okay.
Not necessarily in the sense that there seems like there's a lot of individual parts, just it seems like, just based on how you're describing it, a small change in the angle of this can affect the other pretty drastically.
Most certainly.
And that's the way, I mean, what I see when I see this is I see like you're sitting on an airplane looking at a jet engine, like the front.
The turbine?
Like the turbine on a jet engine.
Sure.
And it's just interesting to see it all taken apart. I've only seen it a couple times taken apart.
So, I have a gentleman, Chris, on the line who sits there and says, spray the hell out of them and push the crank bearings out. LOL. And then Andy says, what fluid do you recommend when changing a converter?
I typically try to not mix fluids, so if you're using a Dex 4 or the factory Ford fluid or whatever, I will stay with that fluid.
Okay.
If we're in a true full race transmission application that's dry, then I'll probably go to a different brand or a different type of fluid. We manufacture our own fluid. We spent 2 years testing and designing our fluid with a gentleman here in Daytona. But generally try not to mix your oil.
Okay. Is the clutch that you guys have for this 6R80 converter, is it any better or worse with a different fluid than this Mercon LV that's normally used in 6R80?
We can have another conversation about clutch materials and fluid. I learned so much working with the guys at Ray Bestis. They have dynos where they apply these clutches with different fluids and see how the torque curve reads as it applies the clutch. And it would be a pretty lengthy conversation, but yes, the fluid does definitely affect the material.
Okay.
These materials will work with virtually any fluid out there.
Okay, sweet.
So Jeff wants to know Sprag versus spragless.
That's a very good question. I actually brought something to talk about that with, Jeff. In a street-driven converter, you want to use a one-way device of some sort, whether it be a roller clutch, a Sprag, or a mechanical diode. Each one has its certain strengths. The roller clutch is the least strong. Then you have the Sprag, which is a dog bone style wedge, and then you have a mechanical diode. And I actually brought one right here. This is a mechanical diode. The Sprag is located in the center of the converter. So let's go over why you have to have it first. So when the fluid's striking here, as the turbine picks up speed, the fluid climbs the stator. Once it gets to where the turbine is spinning 40% of impeller speed, there's no more torque multiplication done. It's all gone. And it's because the fluid's not striking the face of the stator and getting pressurized to the pump. Now it's simply traveling in a full circle trying to make the converter couple. Well, as the fluid tries to get through here, the stator's in its way. If you can see this Sprag race here, I don't know if they can see it. I can move it to where we can. This rotates in one direction and locks in the other. So what happens, when that fluid hits the back of it, it starts to rotate. Once it allows the stator to rotate, then the converter becomes more efficient.
Okay.
Now, the Sprag versus spragless debate. If you take a stator that's designed to be run with a one-way device, whether it be a Sprag, a roller clutch, or mechanical diode, and you make it spragless, chances are the converter is going to overheat. And the reason why the converter overheats, particularly in a street application, is the fluid has to fight its way back through these fins to get around, because this is sitting still, so it has to hit the fin, drive its way through it, get back through it to couple. Once this is allowed to rotate, well then this fin is feeding the other fin, which is feeding this fin, and it just stays in a perfect circle. It's not fighting itself.
So what you're saying is it creates internal pressure in an area where it shouldn't have pressure at that time?
It's still full of internal pressure, but the fluid has to fight itself because it has something sitting stationary in its way.
Okay.
It would be like
flowing with it.
Right. It'd be like pouring a garden hose down your driveway and putting a bush in the middle. It has to drive around the bush.
Okay.
So anytime you alter the direction of fluid, heat's created. At stall is when all the heat's created in your converter in the first place, and it'll cool as it goes down the racetrack. So the spragless debate. If you want to run a stator spragless, remove this piece, that's fine. But you have to have a stator that's designed to be run spragless. Typically stators that are designed to be run spragless will have a flat face on the front of the blade. I don't know if y'all can see this. This has a curved face on it. This is a 1550. So once you get to a flat face and you come and you mill this out, then the fluid can get through there with less restriction. Therefore, getting the temperature out of it. You typically don't want to run a spragless in a street application because it's going to overheat no matter what. Drag racing them, we're running them anywhere from 5 seconds on the quarter mile to 10, 15 seconds on the quarter mile. You're not running it long enough to generate enough heat to worry about it. But if you were to drive this 30, 40 miles down the road, it'll overheat.
Because we're talking about overheating and stuff, what do you consider too much in terms of fluid temperature in a transmission?
Typically, a transmission in a street-driven car should run within 10 degrees of the engine.
Okay.
So if your engine's 210, training needs to be somewhere between 200 and 220.
Okay.
90% of your heat is made right here.
Okay.
Fluid shear is made.
Okay. Nice.
Justin Young chimed in. He says, converter info/tech always hurts my head. It's witchcraftery. F-Body Nation says, FTI Performance for the win. Been running their converter for years.
Nice, nice.
And Zach says, Joe, do you or Justin have a converter in the trucks, or do you plan to?
My converter is stock and Justin's converter is stock.
Shame on you.
It's an otherwise stock truck. I still have stock Michelins on my truck.
We talk about stock vehicles. You can take a stock vehicle, most stock vehicles, GM, Chrysler, or Ford, with today's converter technology that we have, and pick them up somewhere between 4 and 5/10 of a second
That's
on just a converter change, and sacrifice zero fuel economy. Take it to a guy like you, have it tuned, turn off the torque management. Next thing you know, you're picking up 6, 7 numbers. And sacrifice no fuel economy.
Exactly.
That's where
because we still have the magical lockup.
Got the magical lockup clutch. In fact, if you like, we take a second. I can explain how this guy works. We kind of went over what goes on here, what makes this happen. So this clutch has got to be tied to the input shaft in such a manner. So you have a seal in here and you have a seal on the outside. This is a billet lockup piston that we manufacture, and it splines onto here. So these clutches, they spline into the cover and they spline onto the front. They sit in here like so. The transmission makes main line pressure. The converter has converter charge pressure. Converter charge pressure would be, we'll say 100 PSI.
And that,
main
is that
line
the pressure of the fluid coming off the fins inside there?
Correct. That's the pressure inside. Now it's regulated on the inside in the valve body and in the pump.
Okay.
So depending on which unit. The main line pressure is going to be higher than the converter charge pressure. So it feeds main line pressure through the input shaft via this seal. The piston's sealed here. And what it does, if the main line is higher than the converter charge pressure, it floods this. The only way for the oil to come out of the back of the converter is to pass by the clutch. So it pushes the clutch off the cover. That's what keeps the clutch from being locked up driving down the road. Would you want to lock it up? It takes away the charge pressure,
And then the
diverts
clutch
the main line to the converter, which is your converter lockup pressure. Now it has to try to exit, and it pushes it against the cover. That's how simple that works. But once this piston is pushed down against this cover and locks these clutches, now the cover is locked to the turbine hub, hence lockup. No more fluid shear, no more need for torque multiplication, anything. It's 1-to-1. It's like driving a stick shift car down the road.
So your speed ratio is 1-to-1 during converter lockup. Anytime
certainly.
other than converter lockup, you have a less than 1 speed ratio?
Typically, there's some new converter designs that we've been working with and some Pro Mod stuff, Top Sportsman, Top Dragster, in this last year that we were actually showing overdrive.
That's
The
awesome.
input shaft spinning faster than the engine at the finish line. Several cars this year have set records with them using some billet stator designs that we made in a different converter design. I did not bring any of that with me, but we have shown as much as 2% overdrive at the finish line, meaning the engine turning 10,000 the input shaft turning 10,200.
That's awesome. And is that what class of racing do you guys do a lot of work with?
Oh, we're pretty diverse. We do a lot of the street type cars. We do a bunch of street cars. We do a bunch of Top Dragster, Top Sportsman. Bracket racing is very big for us. The monster trucks. We do a pile of monster truck stuff. About 60% of the independents run our transmissions and converters in monster trucks. We specifically designed one just for them, a converter. But a lot of the go fast stuff, primarily drag racing.
Okay.
I have a number of questions coming in. So Jason says, can the torque converter lockup solenoid be unplugged, and will it cause harm to the torque converter?
Most certainly. If the converter clutch stays applied at the wrong time, then it's going to drag this clutch. Or if it doesn't get enough fluid release, it's going to drag the clutch. Another common problem in the 6Rs is the stator bushings. And it's way overlooked by many trainee builders. The stator bushing acts as the seal, like the seal here to the input shaft. The stator bushing acts as the seal to the input shaft inside the pump stator. So when that bushing wears, you're losing oil pressure out that bushing. It's just like having a leak. Whether you're leaking water on the ground, you're leaking oil internally. And what happens when it goes to apply the clutch, it will not fully apply because it's not bleeding off enough oil, or you get enough pressure to it. The other thing that happens is if one of the two circuits leak, now this clutch is dragging. And if the clutch is like partially applied, then it'll burn it up. It's just like dragging your foot down the road. It'll burn your shoe off.
Like a manual car where the clutch is never fully engaged because
Correct.
there's too much preload on the
Breast
on the
plate.
throwout bearing or yeah, like you said, on the pressure plate to where it's not clamping completely.
Most certainly, and it'll fry a clutch out in no time flat.
Especially a wet clutch because they're already lubricated, so they're already kind of designed to slip to a certain degree. Whereas
Correct.
a dry clutch, in an ideal world, it's on-off on
Correct.
a dry clutch. But I can imagine slipping this more than what is necessary could be very detrimental very quickly.
And typically, the solenoid that you're discussing moves a valve.
Mm-hmm.
The valve is what controls it. So if the solenoid hangs, you may get improper timing on clutch apply.
Andy would like to know, would you recommend a different fluid cooler over the stock cooler?
Heat's the #1 killer of any transmission out there. I recommend putting a cooler on your factory vehicle you drive back and forth to work every day. If it's a Prius and it's electric, put a cooler on it. Heat is the #1 killer. If you can get rid of heat, always put a cooler on it. Always. Do these have to have them? No, they won't run any hotter than a factory one. Now, once you start getting up in the higher stalls, in the 4,500 to 5,000s, it's just so much fluid shear going on, you have to put a cooler on it. You
What
stay
do
under 3,500, you're okay.
What do you think about fluid thermostats, like inline thermostats for trans coolers?
Yeah, I'm good with it. They want to bring the trainee to temperature. All the manufacturers want to bring the transmission to temperature now. So you really don't want to bypass your cooler. You want to bring it to temperature, and that's what helps control the lockup circuit in the tunes. And I'm sure you mess with a lot of the tunes on it, so you'll know that they want to bring that temperature up so that it's operating temperature. Everything gets seated, just like an aluminum rod motor. You don't want to rev a aluminum rod motor cold.
Exactly, and a lot of the parameters and tables in the stock ECU are based on trans fluid temp. So like all of your apply pressures and your apply times, boost times, all that stuff, it's either torque based or temperature based.
Correct.
Or both in some tables. So it's temperature is critical, but I wasn't sure from your aftermarket converter standpoint, is it overly detrimental with clutches like this that if they're too cold when they're applied, does it greatly change their characteristics?
I don't believe it greatly changes their characteristics.
Okay.
What the fluid temperature changes, like you said in your tune tables, is pressure. So that's part of what we combated when we built our particular fluid that we built for drag racing, was to maintain a constant charge pressure in the converter over a wide temperature range.
Okay.
This is why the manufacturers don't want to do this until it's at this temperature, because at that temperature the pressure is changing. That's why they have such a big fill window on the stick, because the fluid changes so much with temperature.
Exactly.
So Peyton wants to know, what is normally the first thing to fail on a converter, or why do many converters fail?
Factory type torque converters or aftermarket converters? Factory converters typically have a balloon issue, what's called ballooning. And let's talk about ballooning. That's another big thing that a lot of people want to know about. The reason why these covers are made out of billet, the reason why our hubs in the front of these converters are billet, and they have a big flange on them right here, as you can see where it's welded around, is so that they won't balloon. And what I mean by ballooning is, and everybody thinks the converter's trying to blow itself apart. It's actually the opposite of that. As this thing tries to couple together, the turbine is being pulled into the impeller. As it's pulling it into the impeller is being pulled to the engine. So as these two parts come together, it's trying to push this on the crankshaft. That's what's called converter ballooning. Well, you'll take a converter, if you put enough pressure in it, you'll actually watch this stuff bend. You can watch the front of the converter bend and this bend. We leak check every one at 100 PSI. If you take 150 PSI, put it in a stock converter, put it in the leak checker, and you watch it actually bow. Well, what happens as it bows, it'll bow enough that this bearing that sits on that register will fall off. And then once that bearing falls off that register and it's not on center, chews it right up.
Yeah, especially, I assume once it comes back down to temperature or once it stops ballooning is when it
crunches it
annihilates
right up.
itself.
Most certainly.
With ballooning, do you have to worry about it taking out the thrust bearings on the back of an engine?
Most certainly.
Okay.
Yep. You don't want a converter to balloon. Any performance converter you use, please use a billet cover. I mean, we manufacture some that don't use billet cover, and we tell people, look, keep these things under 400 horsepower. This is something for your street rod to drive to the car show, burn the tire off once in a while. If you're going to go out and drive it like you or I would and enjoy the power that we have, make sure you put a billet converter in it for sure.
Okay. Go ahead, Carrie.
Nymer says, can you explain what stall is in a torque converter?
Stall, I can. Stall is what the engine will push the converter to, how high the engine will rev if you can hold the input shaft still. So a big farce here is with like my converter, I have my 3500 stall and it only stalls 1500. 1500 on a foot brake or 1500 on a trans brake. A trans brake holds an input shaft still. So once it's held perfectly still, that's how you're going to find your true flash point
speed.
or your stall or your converter, because you can floor it. Now, engine torque affects stall. Hence torque converters, not horsepower converters. Torque moves everything. The more torque you put into it, then the higher stall is going to be. So what may be behind a 4.6 that makes 350 horsepower stalls to say 3200 with a trans brake, you take and put it behind a 5.4 that's making 550, hell, it's going to go 3800 because you're putting more power to it. It has the ability to overcome the fluid shear while sitting still.
Exactly.
This goes back to the stators we spoke about, why we change blade angles and so forth, to get the correct stall to match your camshaft, your supercharger, your nitrous kit, whatever, gear, tire, and weight to get the most performance we can out of your vehicle.
To that same end, does a dyno sheet of how the car performs with a stock converter and lockup help you guys tailor a converter to a car?
Locked up, yes.
Okay.
You're looking for that power range. You want to map out the torque curve, and you map out the horsepower curve, so you can figure out where the optimum shift point would be and where the optimum fallback would be. Some people call that shift extension. You can make a converter fall back 1500 RPM on the gear change, make it 2000, you can make it 300. Boosted cars typically don't like to fall back at all because as blower speed slows down, you lose boost. So you want that converter to fall very little on the gear change, keep the boost up, but still have good coupling so that it'll go fast.
Okay.
So you get a few comments. Dean says FTI is #1. David says the Greek goddess can fix any trans. And Greg's pretty good too. Let's see what else we have here. So Einar says, can the added distance of the wheel, if used wheel spacers from the suspension, cause excessive wheel hop on an S550 on sticky track?
Oh man.
The car wheel hop's bad even with BMR cradle lockout.
That shouldn't change whether or not you get wheel hop, but let's try and stay focused on converter stuff. If you have questions about wheel hop or stuff like that, just try and save it for our next show.
Yep. Travis says, at what point does heat affect / damage the converter while on trans brake, spoiling a turbo if it takes 4 to 5 seconds? And is there a better oil brand to run to lengthen the life longevity of the oil and keep the trans / converter safe?
Yes. The heat, as all the heat's generated at stall, just like you had talked about, there's oil manufacturers such as ours. There's a couple other name brand oils out there. LAT makes very good oil as well. The FTI brand fluid is certainly top shelf. It's not an inexpensive oil, it's an expensive oil, but it's designed to do what he's talking about. It's about the polymers being able to stretch and come back without breaking. When the polymers break, that's what creates the heat. You ask what's a tolerable heat in oil, you need to look at your flash point, whether you're using Mobile One, LAT, FTI. All these bottles should have your flash point and your ratings on your oils. The higher the flash point, the more stable the oil is going to be. I'm not an oil expert. I can get an oil expert in here that helped me design mine that would really be good at answering those questions. As far as temperature in the converter, we've got them hot enough to burn the paint off of them, turn them black and blue inside.
Which is probably every bit of 500-600 Fahrenheit.
I've actually shot a converter in the Gravedigger monster truck at over 800 degrees.
God.
Testing. We were trying to break a transmission in a converter, and converter temperature got over 800 degrees in testing. And
have you seen it get
turned
hot
everything
enough
blue.
to blue the rear cover here?
Most
front cover?
Most beautiful blue torque converter you ever seen when you take it apart. Every bearing in it is black and blue, but I mean we do a lot of destructive testing to find out what will they live behind. Correct.
And that's a saying I like to use a lot. You don't know your limit until you pass it.
Most certainly.
Because you can get up to what you think is your limit 100 times, but you don't truly know where the limit is until you go past it.
Find the next weak link.
Exactly.
That's why we make stuff like this right here. Okay. You know, this is your stator designs. This is one of our billet stator designs. We'll get into that in a little bit, but that's exactly why we do that. Because these will reach their limit.
Hell yeah.
So I'm not sure if you want to answer this or not, Joe, but it says, what role does a tuner play in making sure that a transmission holds up?
A lot. There's only so much you can do when you're talking about the amount of torque an engine's doing versus how much the hard parts in the transmission are rated for. But in terms of getting clutches to live and stuff like that, there's a lot that a tuner can do to help increase the lifespan of clutches. In terms of torque converter stuff, there's a little bit we can do, but again, you run into a hard parts limit where a clutch can only clamp so much torque even if it's fully engaged.
Correct.
And like you get into the 900,000 pound-feet of torque range, there's only so much I can do in a tune to save your hard parts.
The next thing that happens when we do clamp that up, at 900, the input shaft's catching all the punishment at that point.
Exactly.
You find the next weak link.
You gotta find that balance of lockup and slip and the point in which to lock everything up and maintaining temperature, like you had said earlier, just
Most
keeping
certainly.
it from getting too hot during all of that. So to answer your question, we can do quite a bit, but we also aren't in control of other stuff.
Right.
That can hurt it.
They can only let you play so much in the sandbox there.
Exactly.
Jeff says, does the wearable clutch material ever clog trans filters or coolers, or are the particles small enough to not worry about?
If the clutch material is plugging a filter or a cooler, then chances are the clutch is coming apart.
Which you probably see weird engagements on lockup and stuff like that.
Oh, you will see all kinds of crazy things. The tune will go crazy. The clutch material is bonded through a heat cycle to these metal plates. You can see on the side of this one right here, this is a metal plate. And you can see the gold color to it. That's a specific glue that they use. And they have patents on all that at Ray Bestis. Of course, Alto makes them as well. Excuse me. To bond the material to it. Typically, when you have a clutch failure, it's due to dragging the clutch, it heats up and it warps. And once it starts bending, it becomes a potato chip. You bend a piece of metal back and forth enough, it breaks. The paper itself will come apart. This material here.
And then you got to worry about it folding and stacking on itself and stuff
Correct.
like that.
And then once it gets in those fins, it turns into a blender. At the point, if your filter's plugged with clutch material or your cooler's plugged with clutch material, you've got a problem, whether it be in the torque converter or in the transmission. You know, there's a problem. The clutch should not ever delaminate in any way, shape, or form. We've gone to great lengths to end delamination in working with the guys at Ray Bestis.
Nice. If you ever have a transmission or a torque converter die or come apart or anything like that, is there any specific procedure you want to see the end user do to ensure that the new torque converter or transmission isn't hurt by all the old debris that's in the lines and in the cooler and stuff like that?
Typically, if you have a torque converter failure, you need to take the transmission apart. Typically, if you have a transmission failure, you need to take the torque converter apart. You know, they say they can flush, so forth. You can't get it all out without taking it apart and actually running it through a hot tank and cleaning it. As far as the cooler goes, they make hot flush systems. They make aerosol tight cans. You can screw to the cooler and flush it out. You've got to get that debris out of that cooler. You go and spend your hard-earned money, build a fancy converter, build a new transmission. When your factory one fails, take it over to you, get it tuned, and 2 weeks later down the road, the thing's not shifting right. So they're calling you going, hey, your tune's wrong, or your torque converter's no good, or the tranny's no good. And actually what it turns out is that the debris that was in the cooler made it back into the valve body of the transmission and hanging up a shift valve. Well, once that shift valve hangs, well, it's all downhill from there. You push it over one domino and it gets them all.
And it's like having an engine fail and not changing the oil.
Most certainly.
You have all that bearing material just sitting in there. So whenever you have a transmission or transmission or torque converter failure, you want to make sure all your lines are clear. Make sure the transmission is torn apart. Make sure all the junk's pulled out of it. All your
100%.
filters are new, all that stuff.
Yes, you have to have a clean environment. 100%. It's got to be clean.
Nice.
Jeff says, is there any truth to the clear tractor fluid performing better than car ATF?
The John Deere High Guard has different specifics. That's the tractor fluid I'm sure he's in question of. That's a popular oil amongst the turbo ranks. And it's because of the viscosity that it has. You have different weight oils you can purchase for it. I'm not an over large fan of the tractor oil. That's part of what put us into the oil business, making our own oil. And we move over 1,000 gallons of oil a month.
That's crazy.
But the oil will always have the ability to act as a hydraulic fluid. All of them will. What typically goes bad in oil is the ability to clean or the ability to lubricate. So you want to make sure that you use the oil needed to do it. The tractor oil is 99% of the time a heavier weight. It's up in a 20 weight versus a 5 weight transmission fluid. What that does is it changes the pressures. If you go put that in like a 6R80 or something that goes back to your temperature in your tune and your pressure in your tune, it totally alters the whole attitude of the computer. It's not understanding how to read, like, whoa, at this temperature I should have this pressure, and the computer starts becoming confused, which makes a tuning nightmare for you. That's why I say I use the recommended oil for that particular transmission. In a race application, Power Glide Turbo 400, I don't have any problem with you using the high guard or any of the tracked oil, but these things need to be relayed to us so that we can adjust the converter charge pressure inside the transmission and the valve body. You don't want to put too much converter charge pressure to it because it's trying to push the crankshaft out the front of the engine. That's where you're going to get your problems with your thrust bearings.
So what I'm hearing here is a lot of what we deal with, where customers buy parts, and after the fact of ordering a tune from us or ordering parts from us, they say, "Hey, my setup's not working right." "What do you mean? I set you up for this, this, and this." "Oh, well, I have this now." And it's like, "Hey, I wish you would have told me that. I would have told you either not to buy that or to buy something else that works a little bit better for your setup." So what I'm getting at here is, if you're planning on doing a build or having a converter built or something like that, have a very comprehensive list of what's going to be in the car and what you're going to do to the car and what you want the car to do with whatever product you're going with.
Most certainly. The more information, the better.
Talk to the manufacturers, man. That's going to be your best bet of making sure your build's going to work properly and live a long time. Talk to the people you're buying parts from. Tell them what you're going to do.
You know what you're going to do with the car, what your intent to do with the car. If you're going to put nitrous on it, if you're not going to put nitrous on it, the whole package. I'm going to put a ring and pinion, I'm going to put a wing on, I'm going to put tires on, I'm going to put a gear in it. The more you tell us, the better we're going to make this. Just like the better you're going to make that tune. If you didn't know the guy was going to put nitrous on it, then he puts nitrous on it.
You might have a bad time.
Right. So please, tell us everything and be as truthful as you possibly can in your build. It's just going to make us look better, make you a happier customer.
Chad says, how is the stall size determined for a PD Coyote setup? As far as low versus high stall?
We can get into picking stall converters. That's something that we probably really ought to get into on a different note or send an email in. There's so many things that affect the combination, whether you're boosted or not boosted, gear, tire weight, like we were talking about. We're going to talk to you, find out what you want to do with the car, what your goals, aspects, what you want to do. Then we're going to design the converter to make it do what you want it to do, and we do that within reason. Sometimes I can't make an 8,000 stall converter that drives on the street every day, but we try to meet your goal the best we can. So, that's really kind of a loaded question. Love to help you. Shoot me an email, greg@ftiperformance.com. Visit my website, FTIperformance.com. Fill out a build sheet, questionnaire. One of the sales guys or myself will get back with you.
Ken says, how much different is the 6R80 converter in a Mustang than a truck?
6R80 converter, 6R80 converter. As far as what we build performance converters. The stock converters are different. But understand, when we build performance converters, we build them per the application. Trucks are typically heavier, it's going to have a more positive fin angle typically, and sometimes we even go to a larger diameter. This is a 245 millimeter. We use 245s, 258s, 265s. We use various different sizes to build converters. So here we go again. It's going to depend on the application and what you're doing to it.
And is the 258, 265, 263, is that the diameter of this clutch face? Or is that
it's the diameter of the actual turbine itself.
Okay.
Right. So, like a lot of times a guy will say, I got an 8-inch converter, but it measures 10.5 inches. Well, that's because it's got a big billet cover on the outside of it. We're actually measuring the turbine diameter on the inside.
Nice.
Poor Boy 313 says, should you or should you not flush a transmission so many miles?
Taking care of your transmission is something that needs to be done on a regular basis. If you're going to do it, do it. Do it on a regular basis. Pick a mileage, 10,000, 15,000, once a year, however you're going to do it. I've been in the transmission industry my whole life, built stock transmissions for many years. Maintenance is something you have to do from the beginning. If you're going to start at the end, don't do it. It goes back to what we were talking about the fluid. The fluid loses its ability to clean. It'd be like trying to wash your clothes with the same Tide 10 times. Well, that last 10th load of 100 is not going to be very clean.
Exactly.
So trannies make metal. Everybody, that's part of life. There's a lot of metal moving parts in there, and they're going to make debris. They're going to show signs of wear and tear, just like you and I do as we get older, signs of wear and tear. This metal, the filter's in that transmission for a reason. The fluid has detergent in it to keep these little small particles in the filter where they belong. So if you don't service your transmission, you put 50, 60, 80,000 miles on it, and you pull that fluid out and you hit it with a fresh detergent, every little crack and crevice is going to have a little black sludge in it, the mud they call. It breaks it loose and goes right to what we were talking about a little while ago about cleaning your filter. Into the valves, hangs your valves, your tranny's not shifting. You service my tranny, now it doesn't move. And I'm sure everybody's heard that before. So yes, servicing your transmission indeed is certainly not a harmful thing. Either do it or don't do it.
Regular intervals if you're going to do it.
Yep. If not, don't touch it at all.
Yep.
So Jeff says, I have a torque converter. It's out to the company it came from to be reinstalled. They said they found metal. Of course, they think it came from the trans. I'm wondering if it could be from the stall itself.
Well, sure it could. I mean, the metal could be coming from anywhere. You have got to look at every piece inside the converter to make sure that you don't have a conflict in two parts. All these parts are spinning at different speeds with a lot of power in front of them. You have to look at the stators to make sure it's not touching the turbo ring, or it's not going down and touching the fin. There's so many places that metal can come from when you have all these spinning parts, whether it be in the tranny or the converter, that you really need to look at it closely regardless who has it. I mean, and it happens. I mean, these things, if this bushing gets wear in it and the turbine's now allowed to move a little bit, when it'll go over and touch the stator, it'll make metal. If there's bushings in the tranny, it can make metal. You know, there's so many things. You have a lot of moving parts between a torque converter and transmission that can make metal.
Significantly more than in an engine.
Most certainly.
The cigar booth wants to know what's the problem with MT82 transmissions?
That they don't have torque converters.
Exactly.
That's basically it. Go ahead.
I was going to say we're caught up on questions at the moment.
Okay.
Let's take a minute and talk about, for the guys who are still watching, I know we spoke a little bit about the stator and stator design, and we got into the bigger power applications. You know, we've focused very strongly on the 6R80 converter. We manufacture a lot of transmissions and torque converters to put 3 speeds or 2 speeds behind race motors, whether they be Fords, Chryslers, GMs. So we do a lot of these behind the Coyote motors with turbo 400s, wild gear ratios, power glide, so forth. When you get into these builds and you're in that 12 to 15, 1700 horsepower range, the stuff that we're going to run on the street in a 500 horsepower converter is not going to work. It all has to change. And I brought along, this is one of our billet stators that we make. These are all made in-house on our CNC machines. This started out as a 20-foot bar of material. And then once it gets slugged out on both sides, then the blades get cut in it, and we have to put this ring on it, weld it, and then finish machine it. But I brought this just to show you. Now this one is obviously a spragless version. There is nothing in the center to come apart. These are the type stators that we use in the higher horsepower stuff. Now, if you wanted to run this in a street type application and you wanted to get into the billet stator stuff, then we simply machine this out, and this is where this mechanical diode comes in that we spoke of earlier in the show. As you can tell, it's like a ratchet mechanism. You can hear it. Now, that's the strongest one-way clutch there is, and it puts the load this way instead of radially, so it's not trying to explode the stator. It's being ridden against 2 bearings. Unfortunately, it's the most expensive, but that's
what you got to do. Pay to play.
Yep. Speed costs money. How fast do we want to go?
Exactly. Now that this billet stator you have here, I noticed that it doesn't have the taper in the stator fins here.
Correct.
So this is flat. So
going
back to what you were saying earlier, how is this changing stall speed or the effective, I think, not speed ratio? What was the...
When we talked earlier, we talked about the use of a Sprag or not a Sprag, and I said that you don't want to run a one-way or a curve face stator in a Spragless situation. That is spragless and it has a flat face.
And then this is mechanical diode. So
correct, this is mechanical diode.
So because you have mechanical diode and this is spragged?
This is spragless. There's nothing, it's solid.
Okay, so spragless and mechanical diode, you want a flatter fin than you do on a curved fin?
Spragless, you have to have a flat face. And to show, and we can see if we can get it on the camera, we talked about why it makes more heat. If you look at the window and the blade on these and compare the two, you can see how much bigger the window is between the blades. So by doing so, you get the fluid through there easier to knock the heat out of it. That's why you need to run this in a spragless configuration. Now, if you take this and put a mechanical diode in it, it'll still work well. On the street, we run a one-way device of some sort just to keep temperature out of it. Even though that blade's thin and it's flat, it's still going to gain more temperature because you're driving it for a continuous period of time and it's having to fight itself.
Okay.
We make these in many different blade shapes, blade angles, blade counts. If you notice, the bottom of the stator is on an angle. This blade's on an angle. This one is not. It actually goes back the other way. All these have an effect of how the torque converter works. So having my own CNC machines and guys in the back that I can go back to with a paper sack and a drawing on it and say, hey, make this, and they can take my dreams and turn them into reality, allows us to come up with some really good stuff.
It seems like it. That seems like a very high quality stator. I haven't seen too many, obviously. I have this one, and then a couple I've seen from like exploded torque converter videos where you see pieces
Oh, yeah.
of everything.
You got just a centerpiece?
Exactly, but this seems like very high quality stuff. So if you guys could, to thank Greg and the guys at FTI, go ahead and shoot over to their page, give them a like on Facebook. I don't know if you guys have a YouTube, but maybe subscribe to their YouTube.
Yeah, we do quite a few YouTube videos on, how-to stuff. Always try to help the racers. I'm in the shop, guys, 90% of the time. When y'all calling, where's Greg? Where's Greg? I'm out in the shop. There's a full sales team in there. I do what I enjoy doing, and that's designing and building bigger, badder, stronger stuff. So, guys, I'm in the shop a lot. We welcome you to come by. Our facility's right over in DeLand. We'll give you a tour, show you what we do. Visit our Facebook page, visit our website, like us. Obviously, these guys are a distributor of ours. If you need any help, you can contact these guys. You can get our product, transmissions, converters, whatever you need. Please stop by. Say hello.
Travis wants to know, is there a difference between how an NA converter is set up versus the same setup but with nitrous on top? If so, how so?
Most certainly. It goes back to stall torque ratio and plus the conversation we had in the hallway a little while ago. But to set a converter up for nitrous versus a naturally aspirated, you're going to bring the stall torque ratio way down because you want the converter to couple harder earlier in the run and then couple harder later in the back half of the run. Nitrous makes as much or more torque than it does horsepower. So, and here we are back to the torque converter again. We have to utilize that torque. So a converter that you're going to spray with nitrous has to be more efficient. If not, it's going to what they call run the converter over. I'm sure you've heard that term. A guy put 200 horse kit on his car and he didn't pick up but a tenth, and he's going, why? Well, you've run the converter over. It wasn't designed to run that nitrous on it. So as that power level changes, then you have to change the design of the converter. Just like a turbo motor, like we spoke about earlier, a variable horsepower engine. An unspooled, they're making 500, spooled, they're making 1,000. That's why you can't put a nitrous converter in a turbo car or a naturally aspirated converter in a turbo car. Here we go again. Totally different blade angle and blade designs. Kind of goes back to the black magic thing you was talking about earlier. It's database. It's trial and error. It's testing. It's tuning. It's learning. It's working with guys like you. Hey, try this converter for me. Let me know what it does. Let's look at the numbers on the dyno. The dyno doesn't lie. It puts the numbers in front of you black and white.
Yeah. Makes it super simple to look at, and it's a lot easier than just looking at a time slip because then you get a reference of RPM and what airflow it's moving, how much spark it's hitting, or how much spark is in it, how the spark is put into it, like whether it's a flat spark curve, which I'm not really a fan of, or how quickly it brings a spark in, how quickly it brings the torque in, all that stuff.
We actually have a top dragster car that is a shop car. We've had several top dragster cars and run a 2 top dragster team for quite some time, some super gas cars, super street cars. Most of the people that work for me are racers, so they're very compassionate about what they do. But where I was going with this, we run race pack systems in ours, and I monitor so many things on it. People laugh at me, right down to every clutch pack has a pressure sensor. The cooler lines have a pressure sensor, a flow meter on it. We had a Pro Charger car that ran 6 flat around 230 mile an hour that we did a lot of testing with it. And that monitoring, that hard data, on those computers, people, it's a computer age. Hard data is it. Anybody can produce a fast time ticket. Go, it went fast, but that hard data is really what has developed all of this in any company that's excelling in a performance game up on their game. Yeah,
that and data is so critical to getting things to be both consistent and you being able to make a converter for your car, know that it's going to work on a XYZ combination, and then take the data you have from that and manipulate it so that it works properly on a different setup.
Most certainly.
Oh man, data.
Toughest guy to build a converter core. I got a 3/4 cam in a 64 Chevy truck.
Nymair says, I switched over from a Mustang to a 6th gen Camaro SS, so I have a question regarding converters and camshafts. Why do bigger cams typically like higher stall converters?
Because your RPM range, when you go to a larger camshaft and you get the overlap in them, your RPM range that the motor makes power moves up. So as it gains in RPM, your power range, you have to bring the converter with it. So let's say your converter at 400 foot-pounds of torque stalls 4,000. We're just going to use for an easy number to work with. And if the motor at 2,000 RPM, the converter stalls 1,800, or so you'll use 2,000, that way it's an even number. So when you change this camshaft and it made 200 horsepower at 2,000 RPM, now it makes 150 horsepower at 2,000 RPM, but at 4,000 it's making 500 foot-pounds. Well, then that converter's got to be looser here to allow it to get up on the motor. The bigger the cylinder head, the bigger the camshaft, the higher the RPM range moves. We have guys with Hemi Brad Anderson motors that we shift at 11,000 RPM in the converter stalls and 94, 9,500. So it's all relative to the power range. The bigger the camshaft, the more converter you have. And by the way, we're one of the few companies that make the converter for the 8L90 GMs as well. Make all the billets for them and the Corvettes.
That's awesome.
Andy wants to know, when changing the converter over a stock converter, how much do you typically pick up in the 60-foot times?
Depends on the suspension and what converter you picked out for it, whether it was a higher stall torque ratio or a lower stall torque ratio. Many times, everybody wants a higher stall torque ratio because it's going to strike the tire harder, which a lot of times hurts their 60-foot because they can't keep the tire planted. Suspension modifications, if you want to run a higher stall torque ratio, you really want to get that 60-foot down, that's fine, but you're going to have to make suspension modifications, change some shocks, trailing arms so you can change pinion angle, so forth. As a typical rule of thumb, on any converter change, we can reduce 4/10 in ET on just a stock converter change. Like I said with a tune earlier, 6-7 is not unheard of.
Yeah, exactly.
But it's getting the car to work is what's really going to affect your 60-foot.
It's about the entire package.
Correct.
And making sure that the converter is right for the entire package and that your car is prepared to handle how that converter is hitting the tire.
Most certainly.
Ken wants to know, do you plan on putting a converter in your truck, Joe?
Probably. I've heard of a lot of issues with the stock converters in the trucks. Once you throw a lot of torque at them, I hear that even in stock form, they have some durability issues. So at one point or another, my truck will probably get a converter. It won't, with how I drive my truck and what I'm looking to do with it, it probably won't get a very big converter.
Sure.
Just something that's stronger than the stock stuff is.
Nightmare says, love the show and learn a lot. Keep up the good work, VMP. And he also says, Greg, you'll be getting an email from me very soon. Need a converter for my NA build.
No problem. Be more than happy to help you.
Kathy and Scott Hartsock said, that guy's a class act. And Luke says, I'm a manual guy, but great information for the auto guys. Great show.
Nice, nice.
Thank you. Thank you for being here with us.
Yeah, and again, if you guys can like, share, and subscribe, both the post and FTI's Facebook page, Instagram, all that stuff. Keep an eye on what they're doing. I'm sure do you guys have anything new coming down the pipeline for 6R80 stuff?
We're always testing and working on it. We're actually working on doing a billet stator design for the street converters in a totally different converter shell format. It's still a 9.5-inch converter, but it's really driven around the boosted application as much as you do. Particularly with the blowers and all boost. Boost is definitely where it's at. Nitrous bottles seem to be laying around collecting dust. Yeah. So we've been putting a lot of effort into some new boosted design converters, not just for the all-out drag race guys, but even for the street guys. 1,000 horsepower street cars every day now.
It's so strange, isn't it? Like 10 years ago, the 1,000 horsepower guys were like top shelf, high echelon guys. All of them were on race gas or E85, and now it's like you see some pump gas cars.
Yep,
1,000 out 800, 1,000. It's like, what? It's crazy.
Drive it to work, get 20 miles a gallon. Oh yeah,
man,
incredible. So we're trying to make bigger, better, stronger. You're not going to catch me sitting on my hands.
Nice, nice.
Jeff says, why do they still say there's a greater rear wheel horsepower loss on auto cars of today that have lockup that should couple every bit as solid as a manual car if when the lockup is engaged?
It's rotational weight.
That, and you're pushing it with fluids.
Fluid. Well, even locked up though, and at this point it's locked up, but you have you have to rotate everything inside that tranny. And there's drag associated with it. Just because a band's not applied, it still has drag. It has fluid. Yep. It's lubricated by the fluid, wet clutch.
Yep.
So they won't put down the number, even with the converter locked up that a stick shift car will.
Yeah.
But they're allowed to accelerate it because the stick shift can't multiply torque leaving the starting line.
Yep. Magical torque converters.
That's all I have.
Okay.
And it's 2:30.
Hot damn. Do you have any other topics you want to hit or anything like that before we take off?
We could do this 2 or 3 times, guys. I just want to reiterate, I appreciate y'all having me on the show. Be more than happy to help y'all. If you'd like me to do it again, let me know. And please contact these guys. Don't cut these guys out of the loop. They do a lot with us. We do a lot of testing, run them on their dyno. These guys are distributors. They can get you the product you need. If you need to contact me, that's fine. If you're already dealing with them, that's great. I'll be more than happy to help. We also, a couple things people need to know, we give a 3-year standard warranty on all of our billet lockup converters. We were the first one in the industry to do that. And we also have an optional lifetime warranty available. And a lot of people take advantage of that. It's $200 and throw it out the back window of your truck. I don't care if you serviced the fluid in it. I don't care if you dropped it off your horse. It doesn't matter. You send it back to me broken, I'll replace it. That's how confident we are in our product. And we give that on our $200 converter all the way to our Pro Mod $5,000 bolt togethers.
That's crazy.
You can buy a lifetime warranty. That's how confident my team and my guys are in our product that we manufacture.
That's awesome.
Stephanie Lorenzo says, hi, Uncle Bubba.
Oh, hi, Stephanie.
And Ken Ingram says, great job, guys.
Nice. And just third person looking in, the parts I see here, you had said earlier, you guys have your own CNCs and stuff in-house.
We do.
This stuff looks like really high quality stuff outside looking in. Even like the welds in here. Is this TIG or MIG weld?
Those are all TIG weld. The only MIG weld we do is to actually put the converter together. We TIG weld even our stators. You can see where the stators TIG welded together. We use different materials to TIG weld them together. And yes, we run all Haas CNC equipment. We have forgings done, rough forging. We finish machine in-house, and a lot of our stuff's made from solid bar stock.
That's crazy. This stuff looks real nice, guys. We've dealt with a lot of your stuff, both converters, and I think a few of my local friends have had transmissions built by you, but always good stuff coming out of your camp. Look forward to doing another show with you, possibly.
Yeah, love to. Maybe you get some write-ins from your customers and so forth, some ideas of what we'd like to talk about. We kind of covered a lot of the basics today. We can get more in depth about gear ratio, how gear ratio affects the converter and so forth. We put together some topics, some ideas. I mean, we're not far away. Love to come back. We'll do it again.
Exactly.
Sure.
And if you guys ever need dyno sheets on setups or anything like that, you can. Joe, this guy says he's got this on 93, or he's one of your customers. Can you hook me up with a dyno sheet for the setup? I can hook you up with that stuff and
Great.
make sure the converter's paired nicely out of the box. Not that it wouldn't already, but the dyno sheet doesn't hurt.
It makes us both look like a hero.
Exactly.
Most certainly.
Jackie Bennett says, the best around at helping you in any way possible. The guys at FTI cut no corners.
Nice. It's always nice to hear customers chime in, because some of these names I don't recognize, so these are some of the guys that you guys are bringing in.
Jackie has a top sportsman Pro Charger car.
Nice.
Yeah, we did a power glide and a bolt. He has a bolt together converter in his car.
Nice.
Yeah. Maybe has an F2X on a 540. Makes somewhere around 1,800, 2,000 horsepower.
I assume like direct crank drive type stuff?
Yeah, F1X, like an F1X12 or an F2X, yep.
That's crazy.
Direct crank drive. We do a bunch of Pro Charger stuff. Pro Charger stuff's getting big. Of course, you know with your superchargers, how big the supercharger game is. I mean, it's boost.
Yeah.
Throw the nitrous bottles away, guys. That's right.
Joe, I have like 2 tuning questions. Do you want to take them or no?
Yeah, we can take them.
Steven says, what percentage of horsepower do you lose from the engine to the tires of an F-150?
Tough call. 4-wheel drive, 2-wheel drive. How big are the tires? What gear ratio is it? But I guess you could say rough math on an auto truck, 17, 18%, maybe as high as 19.
Stu says, I'm interested in having VMP tune a Department of Boost GT500 M122 on a 16 GT. What is the smallest recommended pulley size, ships with 2.875, and claims 10.5 PSI? Thanks in advance.
I'd say that'd be accurate. I've tuned 3 or 4 of the Department of Boost setups. I don't recall what pulleys were on them offhand. I have notes about that stuff. So if you want me to tune a setup like that or let you know what size pulley combination you should run, just shoot me an email or shoot the sales team an email and they can forward it over to me.
And then one last question is, Philip says, so anyone building something cool?
Anyone building something cool? Is that Philip McMillan or PJ McMillan? Or is that
I think it was
someone else?
Philip Boyce,
I don't recognize the name.
but pretty
Nothing
much
I can think of.
most everybody's.
Travis is doing a Fox body with a Coyote and a 6R80. Race car stuff. But I guess we'll leave it at that.
Yeah,
Look
most
forward
certainly.
to
Get some
seeing
emails, get prize put together, and we'll come back on and we can talk more depth about maybe even more race type stuff. I mean, I'm more than happy to help educate the people. It makes everything just so much better for all of us.
Hell yeah. Well, guys, again, Joe with VMP, Greg with FTI. It's good
I
having you on
appreciate
the
it.
show,
Thank
man.
you very much. Yes, sir.
And I guess we'll see you next week on Tuesday, guys.